Hello everyone. This video is on section 8.6 part 1 titled Solving Radical Equations. So in this video I'm going to be going over a version of the Knewton Alta assignment for section 8.6 part 1. Please understand that the version I'm seeing in this video, the questions I see, may or may not be the same questions you see when you work on the assignment on your own. Alright, but the objectives will be the same, the types of questions will be similar, and the way you go about doing them will be similar. So I'm hoping that watching me go through this here helps you in some way when you're working on it on your own. Alright, so here's the assignment page. You will not see the words preview of. Right, you'll only see the title of the assignment, the mastery bar telling you how far along you've gotten, the objectives. Right, it looks like there are 2 objectives in this section, this assignment, and then your questions. Now every question should have below it a feedback button, which allows you to send feedback to Knewton. You will not see the instructor cheat button, and there should be a more instruction button that you can click on. It'll provide you with further reading material, maybe some extra videos to help you when you're struggling with a particular objective. Alright, so we're given here in this objective, it solves square root equations containing a single radical, a single square root symbol. So we have, solve the equation, right? We're trying to find, values of z that'll make this a true statement. And if there's no solution, we're just going to enter the empty set symbol, that little circle with a slash through it. Alright, so I'm going to write this out and write out the steps I'll be following to solve, square root equations containing a single radical. Okay, so we're given here the square root of 2z plus 3 equals, the opposite of z, or negative 1 times z. So off to the side here, I'll write the steps I'm going to be following. The first step is to isolate the radical, which is already done here. See how this expression with the square root symbol is already isolated? Right, it's already on its own side. Get the radical on one side and the non-radical terms on the other. Then I'm going to raise both sides to a power to undo the radical. Raise both sides to a power to undo the radical. Right, I want to take this radical equation and write it as an equation without a radical. So let's take this square root of 2z plus 3 and this other side, negative z, and we're going to raise it to some power. Now this is a square root, so I hope it makes sense that I'm going to raise both sides to the second power. Right. If this were a cube root, I'd raise both sides to the third power. Right. If it were a fourth root, I'd raise both sides to the fourth power, but it is a square root. So to simply undo it, raise both sides to the second power. Alright, so that leaves me without the radical on this side. That's just 2z plus 3. And then negative z squared, right? That's negative z times negative z to be positive z squared. Alright, then you solve the resulting equation. Should be a polynomial equation. Right? No more radicals, no more root symbols. I solve the resulting equation. So this is a quadratic, right? Z squared. So remember what I did here was I took everything to one side, 0 on the other. So I'm going to subtract the 2z and subtract the 3. We have 0 equals z squared minus 2z minus 3. And then factoring this, right, this would be z minus 3 times z plus 1 equals 0. And then we can see the possible solutions here are positive 3. Remember that 0 product property, or the only way a product is going to be equal to 0 is if one of the factors is 0. So either z minus 3 is 0, meaning that z equals 3, or z plus 1 is 0, meaning z equals negative 1. And then, of course, at the very end, this is very important. Check your solutions in the original equation. Always, and you've seen me do this before with equations, right? I'm always telling you, check your solutions back with what they started giving you, right? In the original equation. Right, and this is huge. This is like the most important part, I feel. Because you're going to see that we're going to come across a lot of extraneous solutions in this section. Let's see. So here was the equation again. Right, the square root of 2z plus 3 equals negative z. Now remember, when you see this symbol, this is the positive square root symbol, right? Not the negative one, so be careful. Alright, so let's start with, we'll check z equals 3. We have the square root of 2 times 3 plus 3 equals negative 3. Well, this isn't going to happen. Because over here we have the square root of 9 equals negative 3. Remember, this is 3. Now, when you see this symbol, that's the positive square root. That's 3 on the left side. We got negative 3 on the right side. That is false. Alright, so this is no good. Z equals 3. Remember, that's what they call an extraneous solution. Let me check the other one, negative 1. We'd have the square root of 2 times negative 1 plus 3 equals negative 1 times negative 1, right? The opposite, minus z. On the left side here I have the square root of 1. On the right side I have just 1. You get 1 equals 1. This works. Yes, true. Right. So the only solution here that works in the original equation is negative 1. Right, so please be careful, please, please, please. And you should be doing this anyway with equations. Check your solutions back in the original equation. Right, yeah, so after all that, the only one that works is z equals negative 1. And that's what I'll enter here in this box. Great. And after every question, right, whether you get it right or wrong, there should be an answer explanation. Please read through these. Right, please read through these, whether you're right or wrong. Because if you're correct, make sure that you got it right for the right reasons, and that you didn't just get lucky. Or maybe they go through an alternate method that you might like better and you can use in future questions. Now, if you got it wrong, right, definitely read through the answer explanations and try to figure out where you went wrong, why you were wrong, and hopefully you can learn from your mistakes for future questions. All right, next question. So here's another one. Solve just square root equations containing a single radical. All right, so this time the radical isn't isolated already, so I need to do something real quick, but it's easy enough. All right, so remember what I said, we want to get this radical alone. I want to get this alone, I want to isolate it. So in order to do that, I need to get rid of this plus z here. So I'm going to subtract z from both sides. So now we have this, the square root of negative 6z plus 3 equals, and then negative z minus 4. So now I've isolated the square root, isolated the radical. Now I want to undo the radical, get rid of it, by raising both sides to a power. And because it's a square root, I will raise both sides to the second power. Now on the left side, that just undoes the radical, so I have negative 6z plus 3. Now the right side had multiple terms. Remember what it means to square something. This means take this the right side, negative z minus 4, and multiply it by itself again. Alright, so I'll have to distribute the negative z, and then distribute the negative 4, and then combine like terms. Well, that would be z squared. Then we have plus 4z plus another 4z, so plus 8z, and then plus 16. Alright, so be careful. You don't just distribute powers over here. If you have multiple terms raised to a power, that means you have to take that expression and multiply it by itself so many times. Alright, and now I'm solving this resulting equation. Again, I'll take everything to the right side here. I got 0 equals z squared plus 14z. Right, I would add 6z to both sides. And then subtracting 3 would give me plus 13. Then this factors pretty easily. Z plus 13 times z plus 1. And so the possible solutions here are negative 13 and negative 1. Alright, and I'm telling you right now, negative 1 doesn't work. Because if you put in negative 1 to the original equation, then you'd have to add 1 to both sides. You'd have this positive square root thing equal to negative 3. That can't happen. But negative 13 works. Because if you did that, you'd have the square root of 81 equals 9. And that totally works. Positive square root of 81 equals 9. But again, please don't forget to check your solutions. Sometimes you might come up with ones that don't work out. Yeah, so the only one of those that works is negative 13. Okay, good. And again, please read through the answer explanations. All right. Now this time, we have solve a radical equation with a single radical, or an equation with a rational exponent, right? A fraction exponent. Remember, these fraction exponents can be written as radicals if you so wish. Right. So yeah. Either way, though, you work these pretty much the same way that you did with the square root equations. All right, so I'll write this one out and show you what I mean. So hopefully remember that this is the same thing as the following. I've got 2z minus 12 to the 1/3 power. That was the same thing as the cube root of 2z minus 12. And then you have minus 10, equals negative 12. Hopefully you remember that. Now you don't have to change to radical form. You don't have to do this. You can keep things with the fraction powers. But it's the same thing as before. You isolate the radical. Right, I want to get this alone on its own side. Isolate, or isolate the fraction power. Fraction power, radical, they're both the same. Get that alone. In order to do that here, I'd have to add 10 to both sides. Alright, so now I have, the cube root, cube root of 2z minus 12, or 2z minus 12 to the 1/3 power, same thing, equals negative 2. And then we undo this radical, by raising both sides to the, this is a cube root. So to undo that, I'd raise to the third power. Basically, I want the first power over here, something to the first power. So if you had the 1/3 power, you'd raise it to the 3, right? 1/3 to the 3 would multiply to be 1. So either way, whether you kept the power as a fraction or wrote as a radical, either way you're raising both sides to the third power here. So those undo each other. I'm left with 2z minus 12 on the left. And then negative 2 to the third power would be negative 8 on the right. And then I would have 2z equals 4, right, after adding 12, and then dividing by 2, we get z equals 2. But once again, don't forget to check your answer, right? Now if I put 2 in for z, we'd have 4, then minus 12 is negative 8. Negative 8 to the 1/3 power is the cube root of negative 8. That'd be negative 2 minus 10 is negative 12. That totally works. You'd have negative 12 on the left, negative 12 on the right. So positive 2 is a valid solution here. But please don't forget to check your answers back in the original equation. So z equals 2. Wonderful. And again, please read your answer explanations. Okay, here's a radical, right? Now, if they were writing it with a fraction exponent, you would have 4x plus 4 all to the 1/4 power, right, for the fourth root here. Now I'm going to tell you right now that this has no solution. I'll write it out and show you. Alright, you've heard me say this a bunch in other videos. When you see this root symbol, the radical symbol with an even index, even root, fourth root, square root, sixth root, they're asking you, this symbol is telling you, hey, I want the positive fourth root. So the result over here, what the fourth root symbol is equal to can't be negative, and over here it is a negative. So this will never happen. This will never happen. But let's go through it. All right. So I take the left side. It's already alone, the radical. All right, the radical is already by itself. And in order to undo that fourth root, I'm raising both sides to the fourth power. And on the left side, the radical's gone now. You have 4x plus 4. And then negative 2 to the fourth power is positive 16. And then we'd have 4x equals 12 after subtracting the 4. And then dividing by 4, we get x equals 3. But don't forget to check. Because if I do that, I'll have the fourth root of 16 equals negative 2. But don't forget, like I said a second ago, when you see this symbol with an even root, they want the non-negative one. Sure, negative 2 to the fourth is also 16, but this is asking you for the positive one. This is positive 2 on the left, negative 2 on the right. This is false. This is bad. So this equation has no solution. No real solution, I should say. But this equation has no solution, and they told us in the instructions to, enter that empty set symbol, right, this circle with a slash through it if there's no answer. And that was, well, I guess I'm going to have to go to the sets area and this here, right, and submit. And again, please read through your answer explanations. Next, now we're back to just the square root problem. So I'll write this out and we'll go through it. So once again, I want to isolate the radical first. So I'll have the square root of negative 22w minus 6 on the left. And then I'd be subtracting w. Right, so we have negative w, and then still got the positive 3 over there. And then I'm raising both sides. This is a square root, so I'm raising both sides to the second power to undo that. So the left side becomes negative 22w minus 6, and the right side, as I did in an earlier problem, the right side has multiple terms, so you're not just squaring each term, right? You're taking that entire side and squaring it, right? Multiplying it by itself. Now distributing the negative w and then distributing the 3, I'd get w squared, then minus 3w, so minus 6w, and then plus 9. Now let's solve this quadratic equation. So I'd be adding 22w and adding 6. We have 0 equals w squared, and then negative 6 plus 22 would be plus 16w. Yeah, 22 minus 6, 16. And then 9 plus 6 is plus 15. And we have 0 equals, and then this factors nicely to w plus 15 times w plus 1. So the only possible solutions are negative 15 or negative 1. But don't forget to check. Now negative 15 will work, because if I add 15, I'd have the square root of blah equals 18. That's remember this, the positive square root. That'll work. But negative 1, negative 1 might also work. Because if I put in negative 1 for w, this will be the square root of 16, which is 4, plus negative 1 is 3. They both work. Alright, so I'm going to enter both answers. Right. So back here, it says, if there are multiple solutions, separate them by a comma. So w equals, negative 15, that works, and then comma, and then negative 1. Both of those are valid solutions. And then, wonderful. Once again, please read through your answer explanations. Alright. Then looks like one last question here with just a square root. Alright, and this one's already set up the way I want. Square root, the radical, is already alone on one side, every non-radical on the other. And then we'll undo this by squaring, it's a square root, and do the same thing to the entire other side. The radical's undone, so I'm just left with the radicand, negative 5n plus 14 on the left. And negative n times negative n, right, would be positive n squared on the right. And I'm going to take everything to one side, 0 on the other. So 0 equals n squared plus 5n minus 14. I would add 5n, subtract 14. And then this factors nicely to n plus 7 times n minus 2. And the only possible solutions here then are negative 7 or positive 2. Well, going back to the original equation, let's get rid of these squares. Answer can't be positive 2. Because if I put in 2 for n, this side will be negative 2, and we'll have the square root of 4 equals negative 2. No, remember when you see these even root symbols, that's asking you for the non-negative one. So positive 2 doesn't work. But negative 7 would. We'd have the square root of 49 equals positive 7. All right, the opposite of negative 7 would be positive 7. This one works. So of the two solutions I found, the only one that works back in the original equation, the way it looked, was negative 7. Great. All right, so that objective with the square roots is done. And you've seen with the others, it's pretty similar, right? Just got to isolate the radical or isolate the rational exponent, and go from there. All right, so let me write this one out. It's a fourth root. Remember, I want to get that fourth root alone, so I'm going to take away 7 from both sides first. We have the fourth root of x minus 4 equals negative 2, and I kind of said this for an earlier problem. This is an even root symbol, meaning they want the positive one, not a negative number. So this can't happen. This is going to have no solution. I'll tell you that right now. But if you don't believe it, let's go through it. Raise both sides to the fourth power to undo the fourth root. We'd have x minus 4 equals 16. And adding 4 to both sides, you get x equals 20. But then don't forget to check. If I put in 20 over here, we have the fourth root of 16, which is 2, right? Not negative 2. This is not asking for the negative symbol, the negative root. It's asking for the positive one. It's 2 plus 7. Is 2 plus 7 equal to 5? No, it's not. So the only solution I found, x equals 20, doesn't actually work. So there's no solution, right? No solution to this equation. And once again, if you have no solution, they ask us to enter that empty set symbol, which I'll have to go to sets again. There we go. Great. All right, and then I believe I'll have one more of these. And I'm done. All right, I'm not writing this one. Another fourth root being negative? No way. Now, if you tried solving this, you would end up with a equals 6. You raise both sides to the fourth power, then add 5. You'd have a equals 6. But when I plug in 6 for a, you'd have the fourth root of 1 equals negative 1. But that's not true. That would be 1 equals negative 1. Remember, this fourth root symbol, whenever you see an even root radical symbol, it's symbolizing the positive root. So here I have a positive root being equal to a negative number. That can't happen. So once again, I have no solution to this equation. Now, odd roots are easier. Right? You saw with the cube root earlier. Odd roots can be positive. Odd roots can be negative. It's the even roots that are a little trickier, as you've seen throughout our lessons on roots and radicals. All right, and that should be it for this version of this assignment. Now, please understand, as I said at the top of the video, the questions that I've seen here may not be the same questions you see, but the objectives are the same, the types of questions are similar, how you would go about doing them and working on them would be similar. So I'm hoping that watching me go over these 8 questions here, help you out in some way when you're working on the assignment on your own. And thanks for watching.